Hello everyone, this is a video tutorial of the data mining exercise which we did for our data mining subject. In this project we basically use the SAS Enterprise Miner as our main data mining tool. In this project we are predicting the income level of the employees which has two values, greater than 50k or less than equal to 50k. A number of variables present here are useful for our data set. Some of the useful ones are age, education, marital status, occupation, country, etc. Our data had a number of missing values which we removed by using the filter command in Excel. After using the filter command, we were left with almost 37,000 rows, which was quite significant. And now we shall just go into Weka and see the visualization of these variables and how they are correlated. In this visualization, we see that two variables, capital gain and capital loss, have more values on the left side and hence they are right skewed. We'll take care of this in our SAS Enterprise Miner. So this is the SAS Enterprise Miner in which we have created our project. First we need to import the file, and we can do that by going into the import file tab and then just give the path of our file. Then we go into the Stat Explorer tab and we'll see like how the variables are related among themselves. So first we need to run the Stat Explorer button, and so now after we go into the results tab, we can see like which are the variables which are important for our data and which are not. So this is the output of the Stat Explorer tab. We can see that the variable worth here are relationship, marital status, capital gain, education, etc. And the variables which are not very significant are work class, country, race, final weight, etc. So we'll just close this tab. So we got an overall idea of how the variables are related. And we use this transform variable button to transform the two values which were skewed, the capital gain and capital loss. And now we move ahead into the data partition tab, which we have left as default for training 40, validation 30 and test 30. So we ran our first model, which is a neural network, to just see like how it predicts the variables and how does it classify and what is the classification rate. So when we run the tab, we get to see the results. Clicking on the results, so here is the result from the neural network. Here as we can see that after now 10 iterations, both the curves are like separating, so which is not a good thing. So after coming into this output tab, we can see the different weights which were assigned to the variables and this different outcomes of those weights. And so the neural network was run, and after we go into this view assessment classification chart, we can see exactly like which of the variables were classified correct and which were classified false. So in this the blue ones are correct and the red ones are false. So for less than equal to 50k, the classification rate is like very high, but for greater than 50k it's almost 60%, which is like not very good. So this was the neural network which we built. Now we'll see the decision tree which we built for our model, and we shall compare it with the neural network and see how it performs. So we first need to run the decision tree, and then we get the results. It takes some time as it is on the cloud version. So we just need to wait. So now we see this is the output of our decision tree. Again, when we go into the tree, we see this is the tree which we built. So we knew that the relationship was a very important variable for our data, and so the first split is according to relationship, and after that the transformation is according to capital gain, which was like the second most important variable, and on this side it's then according to occupation, age, a capital loss, and on the left side if we see, on the left side the classification is according to education, then transform capital gain, then capital loss, and so this was the tree which we got. And again, going to the view assessment and classification chart, we can see exactly the number of correctly classified instances for our tree model. So for the less than equals to 50k, our tree does pretty well, as you can see. For greater than 50k, the values are like 50-50, which is not very good. So this was the tree model, and so now we'll see the high performance forest model, in which we built a number of trees and then compare like which tree is best among the given trees. And this model builds a number of trees. So we have the option of choosing the best one among them. So first need to run that model, and so this takes some time. So now we click into the results button, and we'll see the results of the random forest tree. So this is the output of our random forest. We can see that a number of trees have been built, like the frequency and the number of leaves, how many leaves are for the different trees. So when we go into the fit statistics, we see the predictive income and the different variables and values which we get. So now if we go into the view assessment and classification chart, we shall see the values which we get for correctly classified and correctly classified. So for the less than equal to 50k, our tree does pretty well. For greater than 50k, it does better than the decision tree, but not as good as the neural network. So this is the output which we get from the tree, and this has different values and the misclassification rate here, as you can see. So this is not very useful for us. So we'll close this, and so these were the three models which we run. So now let's go into this model comparison tab, run it, and we shall see like which model which we built is the best one. So this gives us an overall idea of the model and which is the best one out of the given three. So from the results we can see that the three graphs that we got are almost basically same, and this is the tree model, tree neural network, and the random forest model which we built, and these are the different parameters which we get after running the tree. The important one here is the test is this test misclassification rate. So the lower the misclassification rate, the better is the model. So the first one which we had is the random forest. So we can see that the 0.139 is the lowest one, and which is for the random forest model. So we can safely say that for our data set, the random forest model gives us the best classification rate, and this output tab we can see the average squared error, misclassification rate, and different values. So, so this was the output of the data which we got, and thus we can safely say that the random forest model was the best one for our data set. That's it.